Hey everybody, so let's go ahead and get started with our Algebra 2 final exam review. This review is going to go over everything for Category 1, which is number and algebraic methods. So this is going to cover a lot of the basic skills that we would have seen over all 9 units for this year, with a lot of little mixes here and there. So let's go ahead and get started. We'll see here that this is a breakdown of our exam. So your entire exam will be 40 multiple choice questions, and you'll have 120 minutes to do them all, so that's 2 hours. So you do have to have a pretty readily paced there. The number and algebraic methods will cover a lot of linear and quadratic factoring, determining sum and difference in product of quotient of rational numbers. We'll be having to solve rational exponents, add, subtract, multiply complex numbers, add, subtract, multiply polynomials. We'll have to determine the linear factors of a polynomial function, rewrite the radical expressions that contain variables to equivalent forms, and analyze domain and range. Okay. You'll see here that this is broken up into calculator and non-calculator. You will have access to the calculator for the entire exam, but there are just some problems that you don't necessarily need them for. So that's the difference here, which again, you will have access to the calculator for the entire exam. So let's look at our first problem here. We have, which of the following is a factor of 216x cubed minus 27? And so we have, and what I want you guys to recognize is we have some cube values here. And what throws that directly in our face is this x cubed. So this tells me, and it should click in your head, that we should be doing either some type of sum of cubes or a difference of cubes. Well, I have a minus sign here, so we're going to end up doing a difference of cubes. For a difference of cubes, we want to identify our a and our b values. Those are going to be, okay, again, those are going to be our cube rooted figures here. So if I wanted to get a, well, that would be the cube root of 216x cubed. If we were to do that, we could break this up into two parts. The cube root of 216 is 6, because 6 times 6 is 36. 36 times 6 is 216. And the cube root of x cubed is x. B, in this case, would be the cube root of 27, and that would be 3. 3 times 3 is 9, times 3 is 27. So from here, all we need to do is follow this little equation of where we're going to be taking this a minus b times a squared plus ab plus b squared. Okay. All right. And so when we set this up, we can start plugging in our values. And so we'd end up getting, well, a is 6x minus b is 3 times a squared, which would be 6x, and all of this needs to be squared, plus 6x times b, which is 3, plus 3 squared. When we clean this up a little bit, we're going to get 6x minus 3 times 6x squared. All that squared would be 36x squared, plus 6x times 3 would be 18x, and 3 squared would be 9. And so this is our factored form of our original problem. Okay, so we need to go through and see, well, which one of these multiple choice questions is a factor? Well, the first one says 6x plus 3. Well, we know that's not true because we have 6x minus 3, so that one there is no good. 216x plus 3, not sure where they got that, that's no good. 36x squared minus 6x plus 9. Well, that looks very similar to our second factor here, but we have a positive 18x, so that can't be right. Okay, so we'll go ahead and cross that out. Okay, and lastly, we would have 36x squared plus 18x plus 9. Well, that's going to be our answer there. Okay, so go ahead and work this one out here. Give you guys some time to finish that up. All right, and then so what we're going to want you guys to do is to go ahead and get started with your problem. And so this one is going to be yours. We've got 125x squared plus 64. Hint, hint, you're not going to necessarily be doing difference of cubes. Again, I repeat, you will not be doing a difference of cubes. So, but you'll have a lot of the same structures here. So give this one a try. If you have any questions, send me a message on Teams. Let's move on. So this one here says, an equivalent form of the complex number 3 minus I squared plus 2 minus I squared is which of the following? So what we need to do here is we have this 3 minus I squared plus 2 minus I squared. So we have to do these squared values here. To do squared, we have to use the box method, or you guys will also know that as the tabular method. And we're going to have to multiply this first term here of 3 minus I times 3 minus I, right? 3 times 3 is 9. 3 times negative I is negative 3I. 3 times negative I is negative 3I. And negative I times negative I is I squared. When we start pulling these factors out, we know that we're going to have 9. These two would combine. Negative 3I minus 3I would be negative 6I. And I squared, okay, I squared, we need to recall that I squared is equal to negative 1. So negative 1. So this eventually just means that this is just 8 minus 6I. I'm going to underline this. This is not our answer, but it is important because this is what we're going to combine with the other tabular method when we do this one here. So let's go ahead and do that one here. So we would do 2 minus I times 2 minus I. Well, 2 times 2 is 4. 2 minus negative I is negative 2I. 2 times negative I is negative 2I. Negative I times negative I is I squared. So when we start pulling these values out, well, we'll get 4. Negative 2I minus 2I would be negative 4I. And again, I squared is equal to negative 1. So this would equal 3 minus 4I. So when we put these together, right, because we're going to take this one as well, we're going to have essentially 8 minus 6I plus 3 minus 4I. We can drop the parentheses. We'd have 8 minus 6I plus 3 minus 4I. And we can start combining like terms. 8 plus 3 is 11. And negative 6I minus 4I is negative 10I. So we have 11 minus 10I. Well, that would be answer choice B. Okay, so this one is a little bit involved. You want to make sure that you do those box or tabular methods correctly, if you may refer to them both ways. And the number one thing that students will forget, and I don't want you guys to forget here, is this I squared equals negative 1. I squared is negative 1. Okay? So now you guys are going to apply that to this one here. So you're going to want a box method 5 minus I, all of that squared, plus another box method or tabular method of 4 minus I, all of that squared. Give that a try. If you have any questions or concerns, send me a message through Teams. All right, so this one says if A and B are solutions to the equation x squared minus x minus 22, all of that to the power of 4 thirds equals 16, find the value of A plus B. So what I did is, already I don't like that 4 thirds, so I tried putting this into Desmos and seeing, man, which are my values. And the problem here, guys, is I got multiple answers, which I should, but I should have only gotten 2. But this is the graph that Desmos comes up with, and so we get values of -5. If this is a -3, well, this would be -3.25. This would be 4.25 and 6. And so the problem here is like, which 2 do we pick? Do we do -5 and 6, -5 and 4.25, all that stuff? So while this is a good tool, it didn't do exactly what we wanted it to do for this question, so we are going to have to apply this one by hand, but we should be okay. So let's go ahead and get this started. We'd have x squared minus x minus 22, all of that to the power of 4 thirds equals 16. So the issue here is this 4 thirds. If I want to get rid of this 4, okay, this 4 part of the 4 thirds, what I want to do is essentially I want to take the 4th root of both sides, because we know that the 4th root and the 4, the power of 4 would simplify out, and that leaves us with x squared minus x, oops, let me take that off there, we got a little bit of a mistake, yeah, so minus x minus 22 to the power of 1/3 equals, well, the 4th root of 16 is 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16, so we're good there. Now I want to undo this cube, or I'm sorry, this 1/3 root here, which is the same thing as a cube root, so to get rid of that guy, we want to cube both sides. So cube and 1/3 simplify out, that leaves us with x squared minus x minus 22 equals 2 cubed. 2 times 2 is 4, times 2 is 8. So now we have a quadratic, and so what we want to do here is we want to set this all equal to 0 and solve. Well, we can do that. We've done that very successfully. If I subtract 8 from both sides, we are left with x squared minus x minus 30 equals 0. Okay, and we know that we can break this down into 2 factors. X times x gives us our x squared. Now we want 2 values added or subtracted that give us -1, but multiplied to give us -30. Well, that would be a -6 and a +5. -6 plus 5 is -1. -6 times 5 is a -30. So we're not done yet. From here we want to get our factors. Well, we know that what makes x minus 6, we take that, set it equal to 0, and we get x equals 6. We do the same thing here. We'll do that up here. We'll do x plus 5, set it equal to 0. We get x equals -5. So this is my A and my B. I'm going to go ahead and circle them. These are not our answers, but these are our factors. The question is stating, what is A plus B? So I'd have to do 6 plus a -5, which is equal to 1. And there's your answer. So again, you can try Desmos. I strongly recommend doing that, because we can already see that our factors of 6 and -5 did come up, and these decimal ones came up as well, but the answer was in there. Okay, we just have to take the time to analyze the question. So you guys are expected to do the same thing here, the same steps, same process, except you don't have multiple choice, so you're going to want to take this one step at a time. I strongly recommend to try graphing this on Desmos first, see if that helps. And then break it down like I did on the last problem. If you have any questions, send me a message on Teams. Alright, so this one says, what is the coefficient of the linear term of the product 7x minus 5 and x squared plus 4x plus minus 2. So we have a product, which means we immediately have to use our tabular method. So I'm going to set up a 2x3 box method here. We'll worry about what the question is asking us in just a bit, but let's go ahead and get this multiplication started. So 7x minus 5 times x squared plus 4x minus 2. We can start multiplying out. 7x times x squared is 7x cubed. 7x times 4x is 28x squared. 7x times negative 2 is negative 14x. Negative 5 times x squared would be negative 5x squared. Negative 5 times 4x would be negative 20x. And negative 5 times negative 2 is a positive 10. So we're going to start pulling out our terms. So we have 7x cubed. And then we see that these two we can combine. 28x squared minus 5x squared would be a positive 23x squared. Then we've got negative 20x minus 14x would be minus 34x. And then lastly a plus 10. Okay, so here it's asking for the coefficient, so we know that's the leading term of the linear term. Right away we can see like it's we have our negative 10. Well, negative 10 is not even an answer choice, right? We're looking at 7, 23, negative 34, and 10. Well, negative 10 is not even a choice. 10 could be it. 34, no, we have a negative 34. Okay, so 10 or negative 34. Well, the issue here is this x cubed, this is our cubic term. 23x squared, this would be our squared term. Okay, this negative 34x, okay, this would be our linear term. And 10 here, if we had just a 10, this is our constant term. So our answer here has to be negative 34. So again, understanding cubic, square, linear, and constant in our place values in these polynomials. Okay, so this one had multiple skills that we had to address. You wanted to make sure that you use the correct tabular method and that you also understand the place values of these constants. So you have the same thing here, but in this question, I'm going to make it very clear. I want you guys to identify the quadratic term. Oh, we didn't talk about quadratic terms. Oh, what would that sound like? Quadratic is it's what's aligned to your squared value. Okay, so go ahead and do your tabular method and identify your squared value for this question. Okay, let's go ahead and move on. Now we have which of these sets gives the extraneous solution. So we have to find an answer that is not essentially true. So when we do this, we want to make sure that we set up our equations. We'll have the square root of x plus 4 plus 2 equals x, and we want to isolate our radical. So what we're going to do is we're going to subtract 2 from both sides. This goes away. I get the square root of x plus 4 equals x minus 2. To undo this square root, I want to square both sides of our equation. So square and square root simplify out. I get x plus 4 equals. So I have x minus 2 squared. So we do need to do a little tabular method here. I can tell you, and I'll do this by hand, in my head. The way I do this, I take the first term and I square it. I get x squared. I take the last term and I square that. Well, negative 2 times negative 2 is a positive 4. And then what I'll do is I'll take the first and the last, which is x times negative 2, which is negative 2x, and then I'll double that, which is negative 4x. But let's do it by hand, just make sure that I did everything correctly. X minus 2 times x minus 2, we get x squared minus 2x minus 2x and a 4. We've got to combine these, so we get x squared minus 4x plus 4. That worked out. Cool. So we've got that, and now we want to solve for our factors. So what I'm going to do here is I'm going to subtract x from both sides, and I'm also going to subtract 4 from both sides. So this simplifies out, so we have 0 equals x squared minus 5x, and then 4 minus 4 simplifies out. So we got to solve for our values here. Well, this is not going to break down. It's not a trinomial. We can't break this into two binomials. But what we can do is we can factor out an x, and we're left with x minus 5. So when we take these two values, we can set them both equal to 0. So we get x equals 0. That's a possible answer. And when we set x minus 5 equal to 0, we get x equals 5. This is also a possible answer. But the question is asking us for extraneous solutions. So what we need to do is we need to check out which of these values doesn't work. So we have to plug these in. So I'm going to plug the first one in here. I'm going to say 0 plus 4 plus 2 equals 0, right? Well, the square root of 0 plus 4 would just be 2 plus 2 equals 0. 4 does not equal 0. This is an extraneous solution. So 0 for sure is an extraneous solution. Now we want to check, what about 5? Well, if I put the square root of 5 plus 4 plus 2 equals 5. Well, 5 plus 4 is 9. The square root of 9 is 3. Plus 2 equals 5. 5 does equal 5. So this is correct. This is correct. But they want us to identify extraneous. Which one was extraneous? Well, our extraneous solution is x equals 0. Quite a bit there, but it's going to take some time. I really like this question, as it tests a lot of skills as far as solving for these roots, identifying how we factor quadratics, works on the tabular method, and extraneous solutions. So this has a lot of layers to it, guys. If you need to play this part again, I would definitely go through this problem again, guys. Let's go ahead and move on to yours. So here you see yours. It's going to be the exact same steps. I want you to go through the same motions and use my approaches to this from the previous problem onto this one. Let's go ahead and move on. So here it says, which of the following notations describes the domain of the function graphed in the figure below? So domain, I want to make sure that we get this correct. Our domain is our left to right. It's our set of x values. Set of x values. So what I would like for you guys to do is always just like come in and draw across the x-axis here and see where do we start and where do we end. So I'm looking here and I see that we're already going to negative infinity. We'll forever go here. So I'm going from negative infinity, and we want to see where do we have a break, right? So we have no breaks here, no breaks, no breaks. When we get to x equals negative 1, okay, we do include that, and then we jump down here. Well, at this point, all these values for x are inclusive, so we don't really have a break here. And then we go on, we go on. So from 0, 1, 2, all of these values exist. We still have all these values existing. Nothing has stopped us yet. And then, oh, once we get to 9, 9 is kind of like where the wall stops. So we're going from negative infinity to 9, and it was a close point, so we do include that. And so this is the way we would write this out in our notation. So let's look at our answer choices. Here it says negative infinity to negative 1, and then from negative 1 to 9. So when they have these double parentheses, they're not including negative 1, but we have to include him because he's included here. So this guy is no good. Here it's saying x is between negative infinity and 9. Now the problem with this one here, and I'm going to erase a little bit here. I'm going to erase this part right there. The problem is it's saying that while we don't include negative infinity, this is correct. It's also saying that we don't include the 9, but we see here that 9 is included. So had this had an equal sign, well, that would have been true, but this part is wrong. Here it says negative infinity to 4. Well, that's not even close, right? It's stopping us way over here at 4. That's actually giving us the range. Okay, this is our range value, so that's no good. This last one here is saying that x, such that x is less than all values equal to or less than 9. So that's true, right? We could write this as x is less than or equal to 9, as if we were to put this on a number graph, right? We could say 9. We'd have a closed point. We're going forever to negative infinity. This guy is the same, it's just written in a different notation. Okay, so now I want you guys to apply the same thought process to this, but here I want you to tell me what is the domain and what is the range for this one. This is going to take a little bit more skills. Remember, your domain would be your x values or side to side, and your range is your up and down. Okay. If you have any questions, let me know. Let's go ahead and move on to the next one. So here it says, which of the following expressions is equivalent? So what they're doing here is they're actually simplifying this. And this is where it gets a little interesting. What we can do here is we can rewrite this as 4a, 8b, 7c, all of this to the power of 1/3. And that's the skill here, is they want you to identify that the cube root is the same thing as raising something to the 1/3 power times 2ab squared c to the 1/3 power. So what we need to do is we need to distribute this 1/3 to all exponents within the parentheses. Well, 4 has an exponent, and the c also has an exponent. If you don't see one, you always assume that it's 1. So really what we have is 4 to the 1/3, a to the 8/3, b to the 7/3, and c to the 1/3 times, we do the same thing here. We're going to do the 1/3 times 1 times 1 times 2 times 1, right, to each one of these terms. So we'd have 2 to the 1/3. Okay. We'd have a to the 1/3, b to the 2/3, and c to the 1/3. And so when we start working through these, we need to recall, like, we want to do this when we are really essentially combining these like terms, right? So we have 4 to the 1/3 and 2 to the 1/3. So let's do this here off to the side. My recommendation is you can definitely put this into Desmos and you'll get your answer. But I want to show you how this works. We don't have the same bases here, but we do have the same radical value. So this is really the cube root of 4 times 2 is 8. Okay, this is a little product rule there, which gives us 2. So we'll get a 2 here as our answer, and I'm going to write this in yellow, 2 here. Then we've got a to the 8/3 and a to the 1/3. So if we were to do that, a 8/3 times a to the 1/3. Well, we do know that when we multiply, we add the exponents. Well, this would be a to the 9/3, which is just equal to a to the 3. 9 divided by 3 is 3. So we have a to the 3rd. So already, I'm sure you guys can see that we can already eliminate c and d. The big difference comes in here with our b values, right? So now let's look at b. So we have b to the 7/3 times b to the 2/3. Well, this would be b to the 7 plus 2 is 9/3, which would be b to the 3rd. Cool. So that already tells us our answer. We're going to finish this off though, but we get b to the 3rd, so we can already tell that a is our answer. But let's just double check that out here. With c, we'd have c to the 1/3 times c to the 1/3 is equal to c to the 2/3, and that works out. Okay, that worked out just fine. Alright guys, so go ahead and finish up your work here. We're going to move on to your problem. This would be your problem set here. Same skills, guys. Same skills, just different values. Be very careful with that exponential multiplication and how you add them up. If you have any questions, let me know. Alright, so let's go ahead and do our last one here. So this last one says, which of these is a factor of the polynomial p of x equals x cubed minus 8x squared plus 9x plus 18. So what happens here with these, and what I don't want you guys doing, is we could test all these values with synthetic division or long division, but that would eat up so much time. And just remember, this is a time test. You only have 2 hours for this. So what I did, and I would, if I was taking the test, this is exactly what I would do, is I put this into Desmos, and I get here that x equals -1, okay, x equals 3, and x equals 6. So that means that my factors for this, I have to kind of like set this equal to 0. If I was going to set this equal to 0, I would get x plus 1 equals 0. This is a factor. X minus 3 equals 0. This is a factor. And x minus 6 equals 0. This is a factor. So these guys here, x plus 1, x minus 3, x minus 6, these are my factors. So if I was to multiply these 3 here, I would get this original equation. So they're asking us, well, which of these is a factor? Well, I have an x plus 1. They're saying x minus 1. This is no good. And then they have these 2 choices here for b. Well, let's see. Let's break down b. If I have x squared minus 9x plus 18. If I was to break this down to 2 binomials, x times x is x squared. 2 numbers added or subtracted, they give us -9, but multiplied give us 18. Well, that would be a -6 and a -3. Okay, well look, -6, this is good, and a -3, this is also good. So it looks like, yeah, our answer here for sure is probably going to be B. These 2 have factors. Okay, all they do is they multiply them together. Let's check C though. If I did C, we would have x squared plus 2x minus 3. We can break this down to 2 binomials. X times x is x squared. I want 2 numbers added or subtracted to give us 2, but multiplied give us -3. Well, that would be -1 and a +3. -1 plus 3 is 2. -1 times -3. Yep. So the issue here is that these are opposites. This is no good, and this is no good. And then as far as none of the above, we've already confirmed that it is B there. Okay? So again, with these, put it to Desmos. That's going to be your best tool. So I want you guys to test, is x plus 5 a factor of this polynomial? Hint, hint, put this into Desmos. Get your factors and see is x plus 5 one of those factors. Okay? Guys, that concludes our Category 1 review. I understand this was a very, very lengthy review. You're not expected to finish this all in one day, but you definitely want to get most of it done today. You will have additional time as we continue this review. At any point you have any questions or concerns, send me a message on Teams, call me up, let me know, and I'll be more than happy to help you. Alright guys, thank you.